All right. For probability, we are starting our probability unit today. And the first thing that we're going to look at is theoretical probability and experimental probability. You should have two papers. The first one is your rock, paper, scissors sheet. And the second sheet is what are the odds? What are the odds? Okay? Now, the first thing we're going to do is look at rock, paper, scissors. We've all played this game before with our friends, and you're going to get to play it today. The first thing I want you to put at the top of your paper above the title, rock, paper, scissors, are these words. Theoretical probability. Write those words, please, on your paper. And then we'll talk about what that means. Write the words theoretical probability at the top of your paper. Okay, what is theoretical probability? Theoretical probability is what we predict will happen. It's what we predict will happen. It's your prediction. Based on mathematics, though. Not just like a wild guess you come up with. It's based on math. And that's what we're going to talk about now. Now, if we're talking about rock, paper, and scissors, what are the only outcomes you can get for rock, paper, scissors? What are the only things you can get if you play it? Rock, paper, or scissors. So how many outcomes are there? 3. So right here on the little piece of paper, you're going to write outcomes, and there's 3 total. 3 total outcomes. Our sample space, we've already stated that. What are the only things you can get when you play rock, paper, scissors? You can only get rock, paper, or scissors. Those are the only 3 things you can get. Rock, paper, or scissors. That's your sample space. Now let's find the theoretical probability of rock. How many times can you get rock in rock, paper, scissors? How many times is it down here in the sample space? 1 time out of how many outcomes? 3. So a third of the time you will get rock. If you actually play rock, paper, scissors, a third of the time rock should win. If you do it right. Okay? What about paper? How many times do you see paper in your sample space? Out of 3. So a third of the time you will get paper as your winner. And what about scissors? A third of the time scissors will win because there's 1 scissors in the list of 3. Do you see how I got these fractions? Your bottom number is your total outcome. Your top number is how many times you see that actual what you're looking for in your sample space list. Okay? Now, let's change each of these to a percent because it's hard to compare fractions. So, calculator. Get your calculator that you picked up from the front table, please, in your hands. Now, here's how we change a fraction to a percent, which you should know by now how to do that. You're going to type in 1 divide 3, then times 100. That's going to give you your percent for rock, paper, and scissors. So 1 divide 3 times 100 equals, what's our percent? So for each time, 33.3% of the time, we should get rock as the winner. 33.3% of the time, we should get paper as the winner. And 33.3% of the time, we should get scissors as the winner. Probability will always be a fraction between 0 and 1. And we'll actually do an experiment and put some things on a number line for probability, that you can see what that looks like. So probability is always a fraction. That's between 0 and 1. Okay? All right. So now that we know our percents and we have predicted what should happen, now we're going to go down here and read these instructions. With the partner, play this game 30 times and tally which position won and who won each game. This is now called, you're going to write this down, experimental probability. Why is it called experimental? You're actually playing or doing the experiment. So write that down. This is your experimental probability. So now we're going to see if we actually play rock, paper, scissors 30 times. Do we get 33% of the time rock will win? 33% of the time paper will win. And 33% of the time the scissors win. Let's see if it actually works out. Here's how we play. All right. I'm going to play, so I'm going to be player 1 and Tanya's going to be player 2. All right, Tanya. You and I, come here. Come over here to me. And we're going to actually play rock, paper, scissors. You ready? Rock, paper, scissors, shoot. Oh, we tied. We don't count that. Rock, paper, scissors, shoot. Oh, we tied again. Rock, paper, scissors, shoot. Oh, I didn't mess up. Rock, paper, scissors, shoot. Rock, paper, scissors, shoot. Okay, she did paper, I did scissors. Who won?
You did.
Who won between paper and scissors? Scissors. So Tanya will go to her paper and I will go to my paper. We'll both put a mark in scissors. Both of us will put a mark in scissors. And who won? I won. So I get a mark and Tanya puts a mark in my box on her paper. Okay, let's go again. One more time. Rock, paper, scissors, shoot. All right, who won this time? Tanya. So scissors gets another mark because scissors won, and then Tanya gets a mark. Okay, see how it works? Okay, you have 7 minutes with a partner to get your 30. Listen, when you add up what you put in here, plus what you put in here, plus what you put in here, all that has to add up to 30. Don't go over 30. So keep up with your totals, okay? All right, you have 7 minutes to work with a partner, one partner, to play rock, paper, scissors at this time. You may begin. Okay, you and your partner should now be finished playing rock, paper, scissors. Okay, I'm going to make up some information to put on mine because I didn't play. So let me do that really quickly, then I'll show you your next steps. So let's say I got rock 10 times, 9, and 11. Okay. So 10 plus 9 is 30. Okay, so put your totals. So count up how many hash marks you had in each one and put your total right here. Go ahead and do that on your paper. Put your total right there. Okay, next thing it says is fractional totals. What's the bottom number going to be for my fraction? Why 30? Right, so 30 has to be the bottom number every time I have to make a fraction because that's how many times I played rock, paper, scissors. Out of 30, how many times did I get rock as the winner? 10. How many times did I get paper as the winner? 9. And scissors, I got it 11 out of 30. So now look at your chart and fill in your 3 fractions. The next one says reduced fractional totals. So now I have to reduce each fraction. My first one's 10 over 30. I know that reduces to 1/3. My next one is 9 over 30. I know that reduces to 3/10. And my final one, 11 over 30, cannot be reduced. So you should now have total, fraction, fraction, total, fraction, fraction, total, fraction, fraction. Do you have that? Yes? I'll give you just a second. Okay, now we're going to change each fraction to a percent, and let's see if we get 33.3, 33.3, and 33.3 each time. So now we have to use our calculator to change each of our fractions to a percent. Top number goes in first in your calculator. Okay? My first fraction is, oh look, I got 1/3. So I'm going to do 1 divide 3 and then times 100. 1 divide 3 then times 100 gives me 33.3% so far. I got the first one right. Did anybody else get 33.3 on the first one? What do you mean? You don't know how to reduce a fraction? Okay, did you reduce it? Okay, go ahead and type it in. Okay, my next one is 3/10. 3 divide 10, then times 100. The next one I got 30%. Oh, I didn't get 33. And my last one, 11 divide 30 times 100. And I got 36.6 repeating percent. I still didn't get 33. Did anybody get 33 all 3 times? Anybody get it 1 time? 2 times? What happened? Why didn't we get 33 for each one? Because what?
Different.
We all have different numbers, different guesses. Why doesn't the experiment match our theoretical? Where did we go wrong? Mathematically, it says we should have 33.3. Let's look and see what this girl did. Now, she's going to take a coin. What's the probability for heads on a coin? 50. 50%, right? What about tails? So if you toss a coin, you should get heads 50% of the time, and you should get tails 50% of the time, yes? Okay, so let's see what happens. Her name's Bianca, and let's see what happens with her. Hit the lights, please. She's at the movie theater first.
You don't like it when I miss the starting movie. There were 2 films I really wanted to see. One is this new dinosaur movie, and the other stars Giovanni, my favorite actor. So when I got to the box office, I don't know which one to pick. I'll flip a coin. Heads, dinosaurs, tails, Giovanni. Heads. I wonder what'll happen if I try that again. Heads. Then? Heads. It doesn't seem fair. Poor Giovanni didn't come up once. That's fair. Even Steven, 50-50. Finally. But that's 3 heads to 1 tail. Doesn't seem fair. So I decided I wanted to do some research on why Giovanni didn't win. Fred's Encyclopedia of Probability. Let's see. 1 in a million, 1 in 1,000, 1 in 100. Here we go. 50-50. When flipping a fair coin, about half the time it will be heads and about half the time tails. See note. See note. Note. This will only happen if you flip the coin many times. Well, I flipped the coin 4 times, but I got 3 heads to 1 tail, and that's not half and half. You have to flip a lot more than 4 times. Hey, do you remember I asked you to hold my plate? Okay, great. Thanks. Wait a minute! Flipping 10 coins 1 time is the same as flipping 1 coin 10 times. Excuse me. I'm trying to find out if I flip a coin a lot of times, but the results really be 50-50. Heads about half the time and tails about half. Will you help me? Come on, it'll only take a minute. How many heads? Raise your hands. Only 3 heads and 7 tails. With 10 coin flips, that's still not very close to 50-50. I need to try this with a lot more people. This better work. Can I grab that for a second? Sure, thank you. Hello? I need everyone to flip a coin to see if heads really does come up about half the time. There's the people who got heads. Raise your hand. How many people here?
350 paid at the gate.
Wow, then it is true. I think I could say that's pretty much 50-50. Thanks. Fred's Encyclopedia was...
Okay, so let's do 171 divide 350. So 171 divide 350 times 100 gives you what percent? 48.8. Is she close to 50%? So what does she have to do to get it close? What'd you say, Tanya? A lot of people. So what do you think happened on rock, paper, scissors?
You have to get a lot of people.
A lot of people? Is it about the number of people?
Number of turns.
The number of turns. How many times did we play it? So how many times should we play it?
50.
Maybe 50?
60, like halfway of 30.
Halfway? Okay, so in order for it to match, we have to play it a lot more times. Okay? We only played it 30 times. Had we played it maybe 50 to 60 times, maybe we would have gotten closer to 33, 33, and 33 each time. And that's what I'm hoping that we can do with our next experiment called What Are the Odds? So go to this paper now. On this sheet at the top, you will see theoretical probability written at the top. And then over here on the side, you will see the word sample space. Y'all see the word sample space? Okay, let's start there with our sample space. Okay, what numbers are in our sample space if we're talking about a 6-sided number cube? What numbers are in our sample space? What can you roll on that die? A 1, a 2, a 3, a 4, a 5, or a 6. Okay, now, how many outcomes are possible? 6 outcomes. So what's the bottom number of our fraction? 6. Okay, good. Okay, you ready? Theoretical. This is what we predict will happen. Okay. What's the probability that the number showing is a 4? What fraction will that be? Look at your sample space. How many 4s do you see in this list? 1 out of 6. Okay, calculator. Let's change that to a percent. 1 divides 6 times 100. What do you get? 16.66 repeating percent. Okay, number 2. The number showing is less than 5. What numbers are we talking about are less than 5 in our sample space? So we're talking about 1, the number 2, the number 3, and the number 4. How many numbers is that from the sample space? 4 out of 6 are less than 5. And what percent will that be? 4 divided by 6. Yes, 66.6 repeating percent. Okay, the number showing is a composite number. What's composite mean? Has more than 2 factors. What numbers have more than 2 factors? What did you say, Ricardo? 4 and 6. Yes, 4 and 6 have more than 2 factors. So we're talking about 4 and we're talking about 6. How many numbers would that be? 2 out of, and our percent will be, yep, 33.3 repeating percent. Okay, next. Number showing is a 6. What will that fraction be? There's 6 6s in our list? 1 out of 6. And what percent will that be?
16.6 repeated.
Yep, 16.6 repeating percent. Okay, next. The number showing is an even number. What numbers are even in our list? 2, 4, and 6. How many numbers is that? 3 out of 6, which is what percent? 50%. The number showing is a prime. Which numbers are prime in our sample space? 1 would not be prime because it has 1 factor, just 1. So 3 and what about 2? Is 2 prime? It has 2 factors, right? 1 in itself. So 2, 3, and 5 are the numbers we're talking about here. How many numbers then? 3 out of 6, which is 50%. Okay, next. The number showing is odd. How many odd numbers do we have? We're talking about 1, 3, and 5. So that would be 3 out of 6, which is 50%. The number showing is less than 3. What numbers are less than 3? 1 and 2. So that's 2 out of 6, which is 33.3 repeating percent. Okay, next, the number showing is a multiple of 2. What numbers are multiples of 2? 2, 4, and which will be 3 out of 6, which is 50%. Okay, on the back, you have these same 9 questions. So we're looking to see if our theoretical is going to match our experimental. Now go up top. This one is called experimental probability, and it says, toss the die, not 60 times. Look up here. You're going to toss it 200 times. 200 times. Okay? So each time you roll a 1, a 2, a 3, a 4, a 5, or a 6, you'll put a tick mark in one of these boxes. When you're done, if you add up your marks from each box, if you add up all your marks from each box, they should add up to how much? 200. So every once in a while, stop and keep count so you don't go over 200, okay? All right, here are your options. I have some hard die that you can throw on the table and put your tally marks down. I also have a page on Canvas for you. Everybody open up Canvas, please. Go to Canvas. We're going here to Unit 5, Probability. And we're going here for lesson 1. What are the odds? Okay. On this page, I have 3 virtual dice for you. You can click on one, and when you open it up, it's going to give you a virtual cube, and you can just click it, and it'll give you a number each time. So if you want to roll a die plus click the die, that'll give you 2 rolls at one time. Kind of speed it up a little bit. If you don't finish rolling your 200 times in class, you got to finish that tonight. So your data for this top part has to be filled in by the time you come to class tomorrow. Do you understand? Okay, send one person over from your table or one person from each row to get a hard dice for your table. And you may begin.